Well, welcome. It's so great to have this space so filled with people. We're so excited that you're here. Um, so to those here in person, to those on Zoom, and to those I haven't had the opportunity to meet, my name is Luke Sullivan, and I'm the executive director of the Well Spirituality Center. And on behalf of my coworkers, Sarah Keneally and Jack Rogers, we're thrilled to welcome you to our program titled A Jesuit Guide to the Stars with Brother Guy Consolmagno, who, like me, is a fellow Michigander. So we're very excited to welcome you to the western suburbs of Chicago. I know some of you on Zoom and here are new to the Well, so I want to just give a brief background on us. We are a spirituality center based here in LaGrange Park, and we were founded by the Sisters of St. Joseph over 26 years ago. Can people hear me here? Oh, thanks. We're not used to having this many people in here. I need to get better at using the microphone. So again, my name is Luke Sullivan, and the Well Spirituality Center is we're a spirituality center based in the charism and the mission of the Sisters of St. Joseph. And our mission is to foster a community that is awakened to our unity with the divine, one another, and all of creation, including the stars. And we do this through programs such as what we're doing here tonight, spiritual direction, retreats, Reiki sessions, and so much more. So I hope those in person will check out some of our upcoming programs and what we have to offer in the table in the back. And then before Sarah introduces our speaker, I just want to remind everyone in person that we have copies of Brother Guy's new book, A Jesuit Guide to the Stars, on sale here in the back after the program this evening. They're located right there, and Brother Guy has kindly offered to sign copies of the book for you if you would like. You can pay by cash, check, or credit card, whatever is your preference. So now, without further ado, introduce Sarah to welcome Brother Guy. Thanks, Sarah.
Okay, so we know we have to get nice and close. So Brother Guy Consolmagno of the Society of Jesus is the Director Emeritus of the Vatican Observatory. A native of Detroit, Michigan, he earned his undergraduate and master's degrees from MIT and a Ph.D. in Planetary Science from the University of Arizona. He was a postdoctoral research fellow at Harvard and MIT, served in the U.S. Peace Corps in Kenya, and taught physics at Lafayette College before entering the Jesuits in 1989. At the Vatican Observatory since 1993, his research has explored the evolution of meteorites and small solar system bodies. Along with more than 300 scientific publications, he is the author of a dozen popular books, including Turn Left at Orion, Would You Baptize an Extraterrestrial, and the newest, A Jesuit's Guide to the Stars. Dr. Consolmagno's work exploring the connections between meteorites, asteroids, and the evolution of small solar system bodies has brought him to every continent on Earth. That's a big claim to fame. And last year, Brother Guy completed the first of 2 terms as the director of Specola Vaticana, Vatican Observatory, a position to which he was appointed by Pope Francis. This newest book is an exploration of the universe and our place in it. Brother Guy offers a path to discover the unbroken connection between scripture, tradition, and humankind's quest to see God in all things, even, or maybe especially, in the stars. Brought to life with more than 70 stunning images of the cosmos, and seriously, the quality is coffee table worthy. Like, seriously, I'm going to leave it out in my house. Brother Guy seamlessly integrates his studies and knowledge as a scientist with his personal journey as a man of faith. His uniquely inspiring story connects the heavens to the earth, the past to the present, and faith to science. So without further ado, here's Brother Guy.
So I don't know whether I'm being cheesy and actually, having an hour-long infomercial for my book, or if I'm being foolish because after you've heard the talk, you don't need to buy the book. I have one more picture to go with this introduction. Last summer, of course, Pope Leo started living with us out in Castel Gandolfo. And on the anniversary of the moon landing, he called up Father David Brown. He knew that the moon was visible in the morning, and they actually got out our old telescope and took a look at it. Astronomy is one of those things that I think really calls us to recognize a universe that's bigger than just ourselves. I'm a Jesuit, and the Jesuits were founded by St. Ignatius. In his autobiography, which was very oddly written in the third person by the guy who wrote down it, in his autobiography, we read, the greatest consolation that he received was from gazing at the sky and the stars. And this he did often and for quite a long time. The Society of Jesus, the Jesuits, are dedicated to becoming close to Jesus. Jesus is God's incarnation within the physical universe. And the Jesuits were men who had all met at the University of Paris with the highest level of scholarship at that time. And so scholarship and understanding the physical universe was what formed them as a society. That unity of hearts and minds that they talk about. They were all students together. You probably remember the people you studied together with and your lifelong friendships that you made. At the universities in those days, before you could go on to your doctorate in theology or philosophy, you had to study arithmetic, music, geometry, and astronomy. They're called the quadrivium. The heart of Ignatian spirituality, the Jesuits, are the spiritual exercises. And these are a series of prayers that you go either through 3 days or 8 days or 30 days, depending on how much time you've got. The common theme is to find the place and identity of God's presence in your life, in the physical universe, in the history, salvation history, and our own personal histories. And at the very beginning, you start with something called the principle and foundation. We are created to praise, reverence, and serve God. The things of the world have been created to help us. We are to use those things that lead us to that goal, and you're indifferent to anything that does it. Maybe it'll help somebody else. Not to desire health or rich or honor, but only that which helps us become what God created us to be. Notice an interesting thing, which I've highlighted with the little red letters. Things, creation. We encounter God in creation. We ourselves are created things. All the things that have been created can lead us to God. The spirituality of the Jesuits is all about our place in creation, why we were created, why the world was created, how we relate to creation. That's the significance of the old Jesuit mantra, to find God in all things. To put it a different way, an Anglican priest who is also a physicist, John Polkinghorne, said, we human beings, we are not apprentice angels. We are not little spirits inside these stupid old bodies waiting to get out. No, these bodies are not stupid. These bodies are what God has made us of. Well, if you're going to be finding God in creation, what's more creation than the universe itself? In the beginning of the exercises, the second week of the exercises, there is this image where we're asked to see the place, the capacity of the world, the three divine persons looking down on the world full of men, determining in their eternity that the second person will join them. This is the world as they're describing, as Ignatius described in the 1500s, before we knew, we had space shuttles. That thin line there, that's the atmosphere of the world. That's what we're busy poisoning right now. But it's also a place of enormous beauty. Astronomy is how we engage in the rest of the universe. And one of the first and really important astronomers, doing this even closer, okay. One of the first and even more important astronomers was Christopher Clavius, a mathematician who worked with Pope Gregory XIII to reform the calendar. And of course, it was using astronomy to work out the dates. He actually came up with a system that allowed you to calculate the date of Easter and all the other feasts connected to Easter using mathematics that pretty much came close to the positions of the moon and the seasons. In his book published in the early 1600s, he calculates the date of Easter out to the year 5000. There it is for the year 2026. Easter happening on the 5th of April.
Oh my God.
He was just a generation ahead of Galileo. In fact, they overlapped. Clavius wrote a letter of recommendation for Galileo and got to look through Galileo's telescope. Now, I don't want to make this a Galileo talk. I'll simply say everything you know about Galileo was probably wrong. The truth doesn't make the church look any better, but it was not a faith science thing. In fact, there were a lot of Jesuit scientists before, during, and after Galileo. One in particular I'd like to point out is Giovanni Battista Riccioli. A recent book about him, if you really want to dig into him, setting aside all authority, this is a colleague of mine, Chris Graney, has looked into the science as Riccioli understood it. And Riccioli, at the end of the day, argues against Copernicus, not on the basis of religion, not on the basis of scripture, but the science didn't seem to work. And it would be another 50 to 100 years before they realized why the science actually did work. But at the time, the best they could measure things, the best they could observe things, it really felt like the science of the Copernican system. There was no evidence that the Earth was moving, and they looked really hard for that evidence. It turns out to be really, really hard to find that evidence. But the idea that the church was, a Riccioli or the Jesuits were vehemently opposed. Riccioli did one thing that lasts to this day. He made the first modern map of the moon and started the system of naming craters for great scientists. And he names the most prominent crater on the moon, Copernicus. And right nearby, he has craters named for Galileo and Kepler and the Greek Aristarchus, who also had that idea. He also named a crater for himself and his student, Riccioli and Grimaldi. And in fact, today there are 35 craters on the moon named for Jesuits. I'm in no rush to get one of those. You have to be dead. On the other hand, you can be alive and get to have an asteroid named for you. So yeah, they made an asteroid of me, and see if you can find me in that list there. There are more than 50 Jesuits now with asteroids named for them. The Jesuit order involved lots of guys who had way too much education, who were fascinated by the universe and things, and who were also sent around the world as missionaries. So that meant that the clergy, especially the Jesuit missionaries, were often the only scientists in the 16th, 17th, and 18th century who would be in places where you could observe eclipses, like this picture of the Jesuits looking at an eclipse from Siam. They were the ones who used the measurements of the transits of Venus to work out the size of the solar system. They were the ones who would gather leaves and classify leaves and characterize and come up with the names of different plants all through India, all through Africa. I could go on for hours and hours about some of these great Jesuit scientists. I'm going to concentrate on one in particular, a fellow named Angelo Secchi. A few people in this room maybe are of an age to remember the books that were very popular in the 50s and 60s, the Don Camillo books. Anybody knows those? Don Camillo was this fictional World War II, post-World War II priest in Italy who came from a very funny little town in the north of Italy, Reggio Emilia. That's where Angelo Secchi also comes from and grew up in a very similar. Angelo Secchi, born in 1818, decides to enter the Jesuits when he's about 15. gets an education in physics, goes off to Rome to get his theology education. He's ordained, and he's about to teach there when the revolutions of 1848 occur. All the Jesuits are expelled from Rome. Garibaldi's armies march in. Angelo Secchi has to flee first to the north of England, where he works at a Jesuit school that has a telescope. So he goes from being a physicist to an astronomer, and then to Georgetown. And he spends a couple of years in Georgetown learning astronomy, learning about meteorology, learning a lot of good science there. Then the French army comes back to Rome. Garibaldi's kicked out. Angelo Secchi can come back. At this point, the Jesuits ask him to be the new director of the observatory that the Roman College has in Rome. Right next to the Roman College is the Church of St. Ignatius. Anybody here been to Rome, seen this church? That's the picture of the church today. You can see that dome is kind of dark looking. The second picture is looking straight up into the dome. It's fake. They ran out of money. They have a flat ceiling. They hired a Jesuit brother to paint the dome in perspective. Why does this matter? It means that the roof of the church has the pillars that were built to carry the weight of a dome, but no dome on them. So Secchi put telescopes where the dome should have been. And with these telescopes, he made some really remarkable astronomical observations. We're talking now the 1860s. The most important was he put a prism in front of the lens, and every star became a rainbow. And he saw gaps in the colors, and they knew just enough to realize that the colors that are missing are the fingerprints of the chemicals where the light had passed. He was able for the first time to measure the composition of stars. A few people had measured 1 or 2 stars. He measured 5,000 and classified them into 3 or 4 different. Now remember, before then, why would the government pay an astronomer? If you knew the positions of the stars, you could calculate the calendar better. Very practical. You could have tables to help navigators or you're sailing across the ocean, observing the stars and calculating where they're very practical. This has no practical purpose whatsoever, and yet it's fascinating. It tells us that the stars are made out of exactly the same chemicals with exactly the same physics as you could find on Earth. He changes astronomy from astrometry, measuring where the stars are, to astrophysics. This is the birth of modern astronomy. But there's more than this going on. It is studying the sky not for a practical purpose, but just for the joy of knowing. And that's remarkable. There is another Jesuit at about this same time, very, very talented, if amateur astronomer, who also looked at the sky, but looked at it in a totally different way. The poet, Jerd Manley Hopkins. The world is charged with the grandeur of God. It will flame out like shining from shook foil, gathers to a greatness like the ooze of oil crushed. Why do men now not wreck his rod? Generations have trod, and all is seared with trade, bleared, smeared with toil, and wears man smudge, and shares man smell. The soil is bare now. nor can foot feel being shod. And yet, for all this, nature is never spent. There lives the dearest freshness deep down things, and though the last lights of the black west went, morning at the brown brink eastward springs, because the Holy Ghost over the bent world broods with warm breast and bright wings. He wrote poems about the stars. Look at the stars. Look up at the skies. The bright burrows circle citadels there. One of my favorites, a very early poem of his, I am like a slip of comet, scarce worth discovery. In some corner seen, bridging the slender difference of two stars, come out of a space suddenly engendered by heady elements, for no man knows, but when she sights the sun, she grows and sizes and spins her skirts out, while her central star shakes its cocooning mists. And so she comes to fields of light. Millions of traveling rays pierce her. She hangs upon the flame-cased sun and sucks the light as full as Gideon's fleece. And then her tether calls her, she falls off, and as she dwindles, shreds her smock of gold amidst the sistering planets, till she comes to single Saturn, last and solitary, and then goes out into the cavernous dark. So I go out. My little suite is done. I have drawn heat from this contagious sun to not ungentle death, now forth I run. A Jesuit who knew the stars, actually there's an astronomer who looked at this poem and said, wait a minute, I know when he wrote it. He's talking about a comet that went between two stars. That's in the third line there. I can identify which comet that was. He's talking about a real comet. We can look and appreciate the skies and the stars, not only as astronomers, but also as poets. At the Vatican Observatory in our meteorite lab, we had this Argentinian chemist show up wearing his own white lab coat. He had an interesting recognition when he talked to our summer school. He reminded us that we do the science for joy. Back in the 19th century, there was a Whig historian, Thomas Macaulay, who wrote about the Jesuits. And he wrote, the Jesuits have a tendency to suffocate rather than develop original genius. Mind you, this is at exactly the same time that Secchi is showing original genius. But notice what Macaulay is assuming why you do the science, to be recognized as an original genius. And that's not why we do it. The motivation behind the work, the glory that comes from it, is the glory of the Creator, not the glory of us. That means that the research is a way of giving glory to the Creator. The research is itself a form of prayer. We do it for the love of truth itself. And of course, this can be seen in the ways that others have looked. This is, of course, St. Francis's prayer, but cited by Pope Francis the Jesuit. Be praised, my Lord, through all your creatures, especially my Lord, brother, Son, who brings the day, who brings life, beautiful and radiant. Of you most high, he bears the likeness. A beautiful sunset, a sunset seen from the surface of Mars. Be praised, my Lord, through Sister Moon. That's our moon. We've been there. We've walked there. We have the dust of the moon on clothing. And this too is part of the creation. that God made and wherein God reveals God's self to us. We praised in the stars in the heavens, you made them bright and precious and beautiful. An image made by our telescope in Arizona. A cluster of galaxies as seen. And a Hubble image of two galaxies, the Whirlpool Galaxy. Each galaxy, a collection of 100 billion stars. And galaxies that run into each other, one of them pulled apart by the gravity as it came through the top and spun around. And within the galaxies, we see the birth and death of stars. This cloud of light is a star. You can see the star right in the center that burped out a lump of gas. And here, we're actually not seeing the gas going out. We are seeing the light from a burst in the star illuminating the gas over a period of months, because it takes months for the light to travel from that part, one part to the next part of the star. This is a cloud of gas that has been compressed by the shock wave of a nearby supernova. And at the ends of those little, the unicorn's ear or the unicorn's crown there, the gas has been compressed into a dust disk that will itself become a new star with new planets. Another such cloud of gas. Notice the stars seem to have a little cross on them. That's the effect of the pieces of wire that are holding up the mirror inside the Hubble telescope. Whenever you see 6 instead of 3, it's the James Webb telescope. They have a different number of spokes holding it up. This is within the nearest galaxy to our galaxy, a little galaxy we call the Large Magellanic Cloud, visible only in the southern hemisphere. And when you observe in infrared light, you can see the places, those red dots, where stars are being formed. You can see two galaxies interacting with each other. And if you wait a billion years or so, you will be able to see how one is consumed by the other. And on a completely different scale, planet Saturn. This is taken with the Cassini space probe. Where's the sun in this picture? It's exactly on the opposite side of Saturn. And the rings that you see are the rings of dust that scatter the light forward, rather than the rings of the ice chunks that reflect the light back to us. And if you look really, 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 really carefully, I don't think I have it highlighted, there is a tiny dot of light in amongst the rings that is planet Earth. Another planet formation region. Stars are made in clusters, and eventually, as they orbit around the center of our galaxy, they get spread apart. So this is a very young cluster of stars. and stars are formed in galaxies. Coming back to my favorite planets here on Earth, this is Jupiter as seen in the infrared. And you notice that thin line of light. Jupiter actually has a very thin ring of dust. And in the infrared, you can see that ring emitting heat waves. 50 years ago, I wrote my master's thesis on the moons of Jupiter. You can see one of them in that one there. At the time that I was writing my thesis, we were beginning to come up with our first idea of what it must have been like when planets were formed. In those days, I had a professor, John Lewis, who loved to take his students to lunch, and then we'd play Frisbee for half an hour before going back in. And we would use the Frisbee as a model for how the solar system was formed. You know, a disk of, you start with a big cloud, but the cloud is spinning. The top and the bottom can collapse, but the gravitation of the centrifugal force would hold the spin up. So you got a little disk. And then one day somebody came in with two Frisbees, and he said, actually, you would have one on top of the other, inverted from what we thought. He was describing what we now see. We can actually see planets being formed around stars. Even in the age of, when we try to understand star formation using models, using computers, we also still rely on images to give us the context of where things are happening. And the Hubble gave us fabulous images in visible light. The Webb gives us images in infrared light. The infrared light can go past dust. If the wavelength of the light is bigger than the size of the dust becomes invisible. So that's why we have the two different telescopes to give us two different pictures, both of them important to show us what's going on in space. The infrared are also the colors that we use to observe the galaxies far away from us, moving away from us faster and faster and redshifted into the infrared as part of the Big Bang. The universe is filled with beauty everywhere we look. These images delight the human eye. Hey, you don't need to have a Ph.D. in astronomy to be able to look at them and go, oh, wow. But then, if the sky's dark enough, you can do that just going outside at night. Go out, like St. Ignatius did, and go, oh, wow. In this beauty, we're reminded that the glory of creation reflects the magnificence of the Creator. Psalm 19, the heavens declare the glory of God. Now, with our astronomical knowledge, the heavens are declaring things that the psalmist could never have imagined. And I think everybody in this room can get a little bit of the flavor of the joy we astronomers get when we get to look at images like these. When looking through the telescope, you feel like you can reach out and touch the face of the Creator. But you don't even have to go that far. Be praised, my Lord, through brothers, wind and air and clouds and storms, and all the weather through which you give your creatures sustenance. 30 years ago, when I was a lot younger, I was part of an expedition that went to Antarctica to collect meteorites. That was a picture I took on a particularly nasty day. But it was as close as I will ever experience to being on another planet. That's where we landed, on the ice, the bay being frozen. And that's where we lived for 6 weeks on the East Antarctic Plateau. This image was taken at midnight, looking due south, at the sun, peering over the South Pole. The way we collected the meteorites was to get into skidoos and go in a line back and forth across the ice. If you saw a rock, easy to do because the rocks are black and the ice is white or blue, you pick it up. Before you got there, you'd all gather around and make measurements and collect it, and eventually they're all sent back to the Johnson Space Center in Houston, where they're stored for scientists to be able to measure them. But it was as close as I'll ever be to being in another planet. It looks kind of like Lake Michigan, except it's frozen. One of the guys with our group brought ice skates and was ice skating up and down hill. And yeah, it had its own little dangers. That's not snow on top of the ice. Those are crevasses. And if you step in the wrong place, you wind up, tumbling 10 to 20 feet. And when the clouds came in, eventually they would obscure any of the shadows. And after a while, you could barely see where the sky ended and the ground began. The little black flag that we put up because that's where we found a meteorite. We were there from just before Thanksgiving until around Christmas time. And then we were going to be picked up. We were flown out to the ice on a C-130 plane that had skis. And we were waiting for one of these planes to come and pick us up. There were going to be 2 of them. One of them landed. We filled it up and got most of our crew there. 2 people were left behind with the rest waiting for the second plane. In the meantime, the first plane, now fully loaded, was trying to take off from the ice and couldn't quite get up to speed. I was in that plane, and the pilot kept looking for lumps of ice that would launch the plane off the ground long enough to be. Finally, we got going. But we were terrified we were going to be stuck there. The second plane comes along. At this point, the clouds have come in. He cannot see where the ground is. There are no shadows. There's no horizon. He's going around in circles. They're talking on radio to the 2 guys left behind, saying, we're going to have to wait a few days until the weather clears because there's no way that we can land here if we can't see the. Oh, never mind, we just found the ground. Antarctica, phenomenal place. And yeah, that's me. Can't you recognize me? I was a little bit skinnier then. But Antarctica is not the only body made out of water. Be praised, my Lord, through Sister Water, useful and humble and precious and pure. This is a moon of Saturn that has cracks in the southern hemisphere, and water from the interior of the moon is being erupted into space. Imagine, if you will, you've got a little rocky planet covered with ice, but between the ice and the rock, there's enough heat to melt the ice. And maybe there's organic chemicals in the ice. Maybe there's intelligent tuna swimming around. Imagine you're in a universe where you can only see the rock below and the ice above, and you have no way of knowing that the universe is bigger than what you can see. You don't know that you're orbiting a planet with rings, that is orbiting a star, that is orbiting in a galaxy, that is part of a cluster of galaxies that's in a universe 14 billion years visible. Which makes you wonder, what are the limits of what we know about our universe? And some of these images are just pretty. Saturn seen from an angle you'd never see from Earth, spacecraft, and the rings of Saturn, and the moons orbiting the rings and Saturn, which come in many sizes. That larger moon in the back is Titan, and it has an atmosphere twice as thick as the atmosphere of Earth. And it has oceans and rivers and rain, but not of water. The water is frozen hard, but of natural gas, which is now liquid natural gas. We actually, well, the Europeans sent a probe to go beneath the clouds. You can see the river valleys, and you can even see the icy boulders on the surface. Another world made by the same creator who made our world. A world that, a universe that has giant craters on and black dust on one side of a planet, of a moon. Bodies where the more volatile gases have evaporated away and left these really wonderfully weird patterns. And then the sun that we're all orbiting. Be praised, my Lord, through brother fire, through whom you brighten the night, beautiful and cheerful, and powerful and strong. This was an image of Venus passing in front of the sun in 2004. A fellow came out to Castel Gandolfo with a telescope to take these images as part of a crew from Sky and Telescope. But his images, I think, are just spectacular. You see a little solar flare. You see Venus. Okay, the guy's name was Ron Dantowitz. Lives in the Boston area. And afterwards, he and his wife joined me for dinner in a restaurant overlooking Lake Albano in this beautiful little village of Castel Gandolfo. And her stepfather joined us. So this was 2004. He was probably well into his 80s. And like the Dantowitzes, Jewish, and he had a number tattooed on his arm. This is also the universe we live in. We have actually, the Soviets have put landers on Venus 50 years ago. Venus is so hot and the atmosphere is so dense that the landers could only last about 20 minutes before all the cameras burned up. So we only have a couple of images. And the other bizarre thing is that the atmosphere is so thick that when you look at the original pictures, it looks like you're in the bottom of a soup bowl. All the light has been bent up. These are images that modern computers have made using the data from the landers to show us what it would look like if we could actually see the surface. Another planet we've been able to look at is Jupiter, a planet made of gas and clouds swirling around the gas. Storms bigger than planet Earth. And it too has its moons. This particular moon, if you see the little moonlight, there's Jupiter, there's the moon. There's a tiny bit of light on the top of the moon. That is a cloud from a volcano. This moon is covered in volcanoes. Because of its orbit, it's being squeezed by Jupiter's gravity to create liquid lava inside, which is erupting into an incredible number of volcanoes. The moon's called Io. I insist it's pronounced Io. Some people will say Io, but what do they know? Actually, I'll accept either of them. There was a reporter once reporting on these volcanoes who said NASA has discovered volcanoes on Jupiter's moon 10. It's Io, it's not 10. And there is a close-up of some of the volcanoes. Remember this image? Okay, that's where planet Earth is. This is the universe that God made. There's a lot of science that we're still working on to try to understand. And 100 years from now, a lot of the things that we think we understand now will turn out to be a little bit more complicated than we thought. But none of these images will be shown to be false, just our understanding of them. This is the universe. This is God's creation. 8 planets, 1 million asteroids, 5 dwarf planets in our solar system. We have discovered already 8,000 other planets in solar systems around stars just close to us. 100 billion stars in our galaxy. 100 billion galaxies that we're able to see, not counting the ones that we can't see because they're too far away. Not just that our telescopes can't reach them, but they're physically impossible for us to see. And yet we know they're there. That's the universe. Those are the things where we find God.
Well, doesn't all of this just make us feel smaller and more insignificant and destroy the thought that God just made me and just made you?
Well, I think it can only do so if we have the wrong idea of God. The problem is we never make God big enough. And that's true of us, it's true of people who professionally think about God. Some theologians don't make God big enough. God is big enough to make everything important. We're not. We have to, I pay attention to you now, I can't pay attention to other people. We're limited. God's not. God can make everything in the universe important. And that's what God does, because God made it and God found everything good.
So I promised to tell you a Jesuit's Guide to the Stars. What makes stars Jesuit? I think it's why we do it, to find God in these things. And we find God especially in the awe that we have when we learn and the joy we experience when we discover. We do it as Jesuits when we engage both the head and the heart, the science, the poetry, the appreciation of the beauty. And we do it when we share what we've learned. That's why we do it, not to hold it to ourselves, but to show the world, to share what we've seen, what we've experienced, what we've discovered, and how we have found God in these things. Thank you a whole lot for coming. And if you want to know more, you can point your camera at that thing and get a QR code that takes you to our website. Or I think Chris has some handouts in the back. Chris, where are you? Someplace there. Of course, you could also just get the book. Right. There's before I open it up to questions, which I'd be delighted to do. I just want to remind you why the Vatican has an observatory. I think you get a sense now. But Pope Leo XIII, previous Pope Leo, when he founded us in 1891, said it was to show the world that the church supports science. The science we do is essential, otherwise we don't have anything to show. But showing the world is also essential. And so that's what I'm going to ask you folks to do. Tell your friends and neighbors that the Vatican has an observatory, that we love this science. We helped invent it. We invented astrophysics. And if you can be part of the Vatican Observatory Foundation, signing up for our newsletter, finding out what we're doing, that gives you more things to share. And if you're teachers, you'll find resources there for your classes. So thank you all, and I'll be happy to take questions. Yes.
Okay, so if galaxies are moving apart from each other, how do they run into each other?
How impressed are you?
Great question. If galaxies are expanding away from each other, then how does it happen to run into each other? Here's the interesting thing. When we say the universe is expanding, I don't mean that I'm expanding. My body is held together by the chemical forces that overcomes whatever the universe wants to. It doesn't mean the Earth is expanding. The Earth has a force of gravity that overcomes that tendency to expand. It doesn't mean that our solar system is expanding. The gravity of the sun holds the planets where they are. It doesn't mean that our galaxy is expanding. The gravity within our galaxy holds the stars where they are. It doesn't even mean that our galaxy is moving away from our nearest neighbor, big galaxy, and the Andromeda galaxy. In fact, the two of them are running into each other. And in about 4 billion years, they're actually going to make one of these spectacular splashes. The expansion of the universe is the expansion of our cluster of galaxies held together by gravity, with the next cluster of galaxies so far away that our mutual gravity between each other is not strong enough to overcome the expansion. That's something that they never bothered to tell you when they said the expansion of the universe. That's one of the reasons why it's so hard to measure, because you have to be looking at incredibly distant clusters and be able to measure their distance to a high precision, which is really hard to do. If you have 25 minutes, I'll explain how.
So if there's 100 billion.
So if there's 100 billion stars, yeah.
Are there 100 billion cells in a body?
If there's 100 billion stars in a galaxy, the best way to the comparison is the number of stars that we can see in the universe is about the same as the number of grains of sand on Earth. Yeah, big number, astronomical numbers, you might even say. Yeah. And God's bigger than all that. Other questions? Yes. How does Teilhard fit into all of this? Teilhard, of course, was the Jesuit philosopher from 100 years before we knew any of this. And like all good scientists, his joy is that he asked the right questions that nobody else asked. I think the answers we come up with now are different from the answers he came up with. That's okay. That's the way it's supposed to work. But he was the one who said, hey, what we're learning in science has an effect on how we understand God. Not in that we can make calculations about God. We can't calculate God, but we can put God into a bigger context. The author of Genesis, who thought that the world was flat and there was a dome from one mountain to the other, said bigger than that is the God who made it. That was as big as they could imagine. You know, 2,500 years later, we can imagine a bigger universe, which just means we imagine a bigger God. And that's what Teilhard was reminding people we ought to be doing. Other questions? Yes. How is physics the study? Physics is the study of the movements of the bodies and a measurement of the forces that cause them to move. So, when you're looking at a star, it's shining. Yeah. Why is it shining? Where did that energy come from? Okay, and some of those colors are being absorbed. That means energy's been ripped out of some of that light. Where did that energy go? Physics is a very complicated bookkeeping system where you keep track of where's the energy coming from, where's it going, and they better balance. That ultimately is the way of thinking of how physics and astrophysics works, which are a whole different set of questions than, oh, what time is it because that star is over there? Both of which is also an interesting question, just a different question. Yes, in the back. What is the research that's exciting me the most? Me personally or me at the observatory? Because it's both. There are a dozen Jesuits at the Vatican Observatory. We come from every continent. We cover everything from quantum gravity and the Big Bang to the nature of dust in our own solar system and everything in between. Each of us is working with a team of scientists who are not Jesuits, who are at universities around the world. My colleagues include a woman who's at the Natural History Museum in London, and a fellow who's at the University of Central Florida, and another Jesuit who's not a part of the observatory but happens to be at Boston College, and so on and so on. So the dozen of us each have a dozen, there's 100 people directly involved. There's another dozen scientists who are not Jesuits, but affiliates. And they can be lay people, they can be men and women, they can be Jesuits and not Jesuits. We even have an Opus Dei priest in that group. We'll take anybody. The things that are exciting to scientists right now, in general, the big questions: how does quantum theory and gravity mix in the very beginning of the universe? Quantum gravity, we don't have a good theory of yet, and so there's a couple of guys in our group working on that. We talked. You probably have heard things called dark energy and dark matter. We call them dark because we can't see them, but we know they're there. One of our adjunct astronomers is working on a big experiment looking for possible particles of dark matter that would interfere and interact with a giant vat of chemical buried in a gold mine in South Dakota. And she's in charge of the data reduction of that system. She's an Italian woman who comes from a little town in Italy that you have heard of. She grew up in San Pellegrino. That's just an example of two of the things. Myself, I'm interested in planets and where planets came from. So for me, the excitement is seeing these new planetary systems and seeing that a lot of the things that we thought we understood about planets turn out to be not quite as true as we thought. And that means time to go back and redo a lot of, rethink a lot of what we've been thinking of. Finding out that you were wrong is the most exciting. Isaac Asimov had this marvelous line: what's the most exciting thing you hear in the laboratory? It's not, I found it. The most exciting thing is the guy going, huh, that's funny. So yeah, that's the kind of stuff that we're excited about. In the back there, yeah. Are we following Artemis 2? I'm saying this so that people can hear. And what did I think of the images? Of course, we followed them. How could you not be excited? Oh, come on. That's not a mission that we are directly involved in. We have guys who are involved in the OSIRIS-REx mission that brought samples back. We've measured some of those samples. One of our guys is involved in a mission to the asteroids out by Jupiter, the Lucy mission. Artemis, we don't happen to be directly involved in. I'm excited because it reminds me of 1968. It was the day before Christmas, in a really terrible year for the world, when suddenly we were reminded of what the human race could do when we worked together. And here it is the day after Easter. And once again, in a really torn up world, to be reminded of what we can do. So that in itself is a sign of hope in a world that needs signs of hope. Also, it's really cool. Yes. Is there an official opinion of the Vatican Observatory about life outside, especially intelligent life? There's no official opinions about the observatory about anything. That's not what we do. And in fact, that's not what the Vatican does. The Vatican is a really dinky place. It's about the size of a high school. And there's one cafeteria that everybody goes to at lunch, and they've got their own cliques of who sits at what tables. But we are not afraid of the possibility of intelligent life elsewhere. I'm not going to tell God what he can do or not do. I actually myself serve on the science advisory board of the SETI Institute that looks at search for extraterrestrial intelligence. And here's why we're excited if ever we could see radio signals from another. It's not because we think we could understand them or communicate with them, because they're probably going to be 50 or 100 light years away, which is, oh, that's what they were saying 50 years ago. Hey, we're here. And you have to wait another 100 years before they go, what was that again? But if we found intelligent life elsewhere in the universe, that would mean that we found life in the universe, which we haven't done yet. And we're desperate to know, is life typical and common, or is it something incredibly rare? I mentioned the 8,000 planets. None of them look anything like Earth. You see the press release, oh, we found an Earth-like, when you look, it's not Earth-like. Really is not Earth-like. We finally know that the sun is a star, but very few stars are like the sun. We know that the Earth is a planet, but we haven't found any planets that are like it. What we've got here, so far as we can tell from the statistics of a few thousand, is something really unusual. If there is intelligence elsewhere, not only in space, but maybe in the past or maybe in the future, it's probably not anything that we'll be able to communicate, but simply knowing that it's there. Well, would that violate anything in our theology? Don't we have angels created by God, intelligences that are different? Don't we see in Scripture phrases like the stars sang with joy to their creator? Now, I don't think that stars are actually intelligent and actually sing. Oh, I don't know, maybe. But what I do know is that whoever wrote that is not afraid of the universe being filled with other entities that can sing with joy about the fact that they have been created. So the answer is, I don't know. Let's find out. I think we have time for maybe one or two more questions. Yeah. Sorry. How did I get? Was it the stars that led me to the Jesuits? By a remarkable coincidence, the book has the same title as my talk. Yes. Yes and no. I was a Sputnik kid. I started kindergarten when Sputnik was launched. I was finishing high school when we landed on the moon. So of course I was going to be space crazy. My dad loved astronomy and taught me the stars, and he was a navigator in World War II, so he learned the stars professionally. That love of the sky was, for me, at first a substitute for being a Jesuit. When I was in my first year at Boston College, I discerned a vocation to be a priest. And God's response when I was praying, I mean, the Jesuits told me to pray. I'm like, I'm 18, who prays? Okay, prayed. When God very surprisingly said, no, you do not have the vocation to be a priest. I mean, among other things, priests like, listen to people with problems, and you're terrible at that. Every time somebody in my dorm, one of these drunken freshmen would come up and say, of course you got problems, you're an idiot, what do you think? I'm told that's not good pastoral care. And that's why I left that school and joined MIT, because I figure if I'm going to be a nerd, okay, I'll be a really good nerd. It was only after 20 years, getting my doctorate, teaching it and doing science at these places, teaching at the University of Nairobi, teaching at Lafayette College in Pennsylvania, I discovered I really liked small college teaching. And that point, God said, you could be a brother. So I joined as a brother, thinking that I'd get to teach at a place like Loyola. But except for that vow of obedience they made me take. And under obedience, without me being asked, I was ordered to go to the Vatican Observatory, live in that miserable palace, eat that terrible Italian food, and do whatever science I thought would be good science. Under obedience, I had to do it. And one last question, anybody? Yes, in the back. What did I think of the movie The Hail Mary Project? I haven't seen it yet. I love science fiction, but I've got my own peculiar tastes. A friend of mine gave me the audio version book, and I've fallen asleep twice listening to it. And the problem is not the book, the problem is me. It scratches an itch that I don't have. What's the universe expanding into? That's a classic good, bad question. It's good because it means that I can grab at for understanding. And bad in that it's almost impossible to explain it. The universe is not expanding into something. The space between the clusters of galaxies is itself growing. Each of the galaxies thinks it's standing still. But the distance between me and it's as if we're all in this bunch of chairs, and the floor starts getting bigger. And the space between the chairs is getting bigger. And we're all being carried along. But it is space itself which is expanding. And here's a connection between faith and science. Much like the Trinity, if you think you understand the Trinity, if you think you understand the expansion of the universe, then you got it wrong. And yet, there it is, which means we'll never run out of things to think about, ways to think about it, maybe even better ways to explain it. Thank you, everybody, for coming here. This has been great.
I think I need to re-listen to that 4 times before I have single understanding. So thank you so much for coming. Thank you so much for being here. For those in person, thank you so much for spending your night with us. For those on Zoom, thank you so much for being here. Again, as a reminder, we have Brother Guy's books in the back corner. We encourage you, please consider purchasing one. They'll sign a copy for you. Also, in the back right, I think we have a lot of our upcoming programs here at the Well. I hope you'll consider participating in this with us. Speaking of faith and science, Dr. Chris Baglow, who is the director of the McGrath, do you know?
Oh, yeah, very well.
The director of the McGrath Institute at Notre Dame is coming during the season of creation to do a talk on faith and science on September 20th.
Show up to that.
We'll get you recording that. Yeah, so I hope you all will come back to participate in September 20th on a Sunday, 12 to 3 in this room. They'll be here in person. As is our custom here at the well, we offer a blessing to all of our presenters. So I was wondering if you'd be willing to go it here. And I would invite everybody to stand up and extend your hands and blessing. Sister, those on Zoom, if you wouldn't mind muting yourselves and do the same thing. Thank you so much, Brother Guy, for your wisdom, for your insight, and for all that you've done for all of creation. So now we'll repeat after Sister Kathy in the back for the blessing.
God be with you. Peace around you. The presence of God be with you. God be with you. Peace around you. The presence of God be with you.
Amen.
Thank you so much.
Thank you.